Git and GitHub, from absolute zero. By the end of this you will understand what Git actually is, you will make your first repository and your first commits, you will branch, merge, and rebase, you will push to GitHub and open a pull request, and, the part almost nobody teaches beginners first, you will have the disaster recovery safety net, so that no matter what you break, you can get your work back. We will go in the order you would actually learn it, first what Git even is and why every developer on earth uses it, then Git init, Git add, and Git commit to make your first snapshots, then branches, so you can work on something without breaking your main code, then merge versus rebase, the one topic that confuses everyone, explained simply, then GitHub itself, remotes, pushing, cloning, and pull requests, the way real teams collaborate, then the undo safety net built around Git reflog. Because nothing you commit is ever truly lost, and finally the daily workflow that ties it all together, the exact loop professional developers run every single day. No prior experience needed. Let us start with the question underneath all of it, what is Git? So what is Git, really? Git is a distributed version control system. Version control means it tracks the full history of your project over time, so you can see what changed, when, and by whom, and jump back to any earlier version whenever you want. Distributed means every copy of the project carries that entire history. Git does not need a central server to work. The thing Git tracks is called a repository, or repo for short. A repo is just your project folder plus the complete history of every snapshot you have ever saved. Each of those snapshots is called a commit. A commit is Git's word for a saved point in your project's history, like a checkpoint in a game you can always return to. Here is the key idea that trips up beginners: Git is local first. All of your commits and your whole history live right there on your own machine, in a hidden folder called .git inside your project. You do not need the internet, and you do not need GitHub, to use Git. So then what is GitHub? GitHub is a website that hosts a copy of your repository in the cloud, a remote, so you can back it up, share it, and collaborate with other people. Git is the tool, GitHub is one popular place to put your repos online. GitLab and Bitbucket do the same job. Keep that split clear in your head and everything else clicks into place. Git is local and does the version control, GitHub is remote and does the sharing. Let us make your first repository. Go into your project folder and run git init. That single command creates the hidden .git folder and turns an ordinary directory into a Git repository. You only ever do this once per project. Now, the mental model you must have is that Git has three areas your files move through. First, the working directory, the actual files you see and edit. Second, the staging area, also called the index, a holding zone where you gather exactly the changes you want in your next snapshot. And third, the repository itself, the permanent history of commits. Files flow left to right, working directory, into staging, into the repository. Run git status anytime to see where everything sits. When you are learning, run it constantly, because it tells you what changed and what is staged. To move a change into staging, run git add, then a file name, or git add. To stage everything at once. Then git commit -m, with a short message in quotes, takes everything in staging and records it as one new commit in the repository. That message should say what the change does, for example, git commit -m, add login form. To see your history, run git log, or better, git log --1 line, which shows one tidy line per commit with its short hash and message. That is the core loop of Git: edit files, git add to stage, git commit to snapshot, git log to look back. Everything else in Git is built on top of these three areas. Now branches, the feature that makes Git powerful. A branch is a movable pointer to a commit. That is the whole definition. Your main line of work is a branch called main, and main is just a pointer that moves forward to your newest commit each time you commit. Why would you want more than one branch? So you can work on something new without touching your stable code. You create a branch, do messy, experimental work on it, and main stays clean and shippable the entire time. If your idea works, you fold it back in; if it does not, you throw the branch away and main never knew. To create a branch, run git branch, then a name, for example, git branch feature. But creating it does not move you onto it. The modern way to create a branch and jump onto it in one step is git switch-c, then the name, git switch-c feature. The -c means create. Now you are on the feature branch. Every commit you make moves the feature pointer forward while main stays exactly where it was. To go back, run git switch main. You may also see the older command git checkout used for this, git checkout feature to switch, or git checkout-b to create and switch. Checkout still works everywhere, but newer git split it into git switch for branches and git restore for files, which is clearer and harder to misfire. So, git branch to create, git switch-c to create and move, git switch to hop between them. Branches are cheap, instant, and the heart of every Git workflow. Once your branch is ready, you bring its work back into main, and there are two ways to do that: merge and rebase. They reach the same destination by opposite routes, and picking the wrong one on shared code causes real pain, so let us keep it simple. Merge first. You switch to the branch you want to receive the work, git switch main, then run git merge, then your branch name, git merge feature. Git combines the two histories exactly as they happened and, if they diverged, ties them together with a single new merge commit. Nothing already recorded gets rewritten; your history is a true record of what actually occurred. Merge is safe on shared, public branches, that is the one to reach for by default. Rebase is the other route. From your feature branch you run git rebase main. Git lifts your branch's commits off and replays them one by one on top of the latest main, giving you a clean, straight, linear history with no merge commit. It reads beautifully, but here is the catch that matters: rebase does not move your commits, it recreates them, so every replayed commit gets a brand new hash. That is perfectly fine for commits that only live on your own machine. It is dangerous for commits you have already pushed and shared, because everyone else still has the originals, and now the two histories disagree. So the golden rule, the one thing to remember: rebase your own local, unpushed work to tidy it up, never rebase commits other people already have. Merge is safe and honest, rebase is clean but local only. So far everything has been local, on your machine. Now let us get your repo onto GitHub so you can back it up and share it. First, create an empty repository on GitHub in the browser. It gives you a URL. Back in your terminal you connect your local repo to it with git remote add origin, then that URL. Origin is just the conventional nickname for your main remote. You are telling Git, when I say origin, I mean this GitHub address. Then you send your code up with git push-u origin main. Push uploads your commits to the remote. The -u, short for --set -upstream, links your local main to the remote main so that from then on you can just type git push and git pull with no extra arguments. You only need the -u on that very first push. Going the other direction, to get an existing project from GitHub onto your machine, run git clone, then the URL. Clone downloads the entire repository, full history and all, and wires up origin automatically. That is how you start working on any project that already exists. And git pull brings down commits your teammates have pushed and merges them into your current branch. Remember, pull is fetch plus merge, not just a download. One more distinction people ask about: cloning copies a repo you already have access to, while forking makes your own personal copy of someone else's GitHub repo under your account, which is how you contribute to projects you do not own. Remote, push, clone, pull, that is GitHub collaboration in 4 commands. Now the piece that makes GitHub a collaboration platform and not just a backup drive: the pull request. Here is the flow. You do your work on a feature branch, commit it, and push that branch up to GitHub with git push. Then, on the GitHub website, you open a pull request, a PR, which is simply a proposal that says, please review my branch and merge it into main. A pull request is not a Git command, it is a GitHub feature. It opens up a page showing exactly what your branch changes, line by line, and it becomes the place where your teammates review the work, leave comments, request changes, and run automated tests against it. This is the whole point, nothing goes into main until someone has looked at it. When the reviewers are happy, someone clicks merge, and your branch's commits become part of main on GitHub. Then everyone runs git pull to bring that newly merged main down to their own machines, and the cycle repeats. Even working solo, pull requests are worth using. They give you a clean record of every change and a moment to review your own work before it lands. If you are contributing to a project you do not own, the pattern is, fork it to your account, clone your fork, push your branch, and open a pull request back to the original project. Branch, push, open a PR, review, merge, that is how code gets into a shared code base, safely. Now the safety net, because you will make mistakes, and the calm truth is that nothing you have committed in Git is ever truly lost. Start with the small fixes. Just committed and the message has a typo, or you forgot a file. Do not panic and do not reset, run git commit -- amend, which rewrites that last commit in place. Want to undo the last commit entirely? Git reset -- soft head -1 removes the commit but keeps all your changes staged, ready to redo. Git reset -- hard head -1 removes the commit and throws away the changes too, powerful, but the one to respect. Now, if the bad commit is already pushed and shared, do not rewrite history, run git revert, then the commit's hash. Revert creates a brand new commit that undoes the old one, so nothing is deleted and nobody else's history breaks. Revert is the safe choice on shared branches. And here is the star of the show, the one command to burn into your memory, git reflog. The reflog is a local log of everywhere your head has been, every commit, reset, rebase, and switch. So when a commit seems gone, you reset too hard, or deleted a branch, run git reflog, find the entry, read off its position like head at brace 2, and run git reset -- hard head at brace 2 to jump right back to it. Reset moves a pointer, it does not erase commits, and the reflog remembers where they went. That is the mindset that makes Git safe to experiment with. Worst case, you reflog your way back. Let us tie it all together into the loop real teams run every day, so you know the exact order. 1. Git pull, to start from the latest main. 2. Create a branch for your task, git switch -c, then a name like fix login. 3. Do the work, and commit as you go with git add and git commit -m, in small, meaningful steps. 4. Git push to send your branch up to GitHub. 5. Open a pull request and get it reviewed. 6. Once approved, merge it into main. And 7. Delete the finished branch and pull main again, so you are clean and current for the next task. Pull, branch, commit, push, PR, merge, delete, that is the entire daily rhythm, and you will run it thousands of times. One more essential habit that belongs here, the .gitignore file. It is a plain text file in your repo where you list files and folders Git should ignore and never track, things like your node_modules folder, build output, and anything with secrets, like a .env file holding API keys or passwords. Add a pattern to .gitignore and Git pretends those files do not exist. This keeps your repo clean and, critically, keeps secrets out of your history, because once a password is committed and pushed, scrubbing it back out is genuinely hard. So set up a .gitignore early, on day 1. Master this loop and a good gitignore, and you are working exactly like a professional. That is Git and GitHub, from zero to a real daily workflow, in one frame. Git is a distributed version control system, a repo is your project plus its full history of commits, and it lives locally on your machine. You make history with git init, git add, and git commit, and the three areas, working directory, staging, repository, are the model underneath all of it. You isolate work with branches, git switch-c to create and move, git switch to hop back. You combine work with merge, which is safe and preserves history, or rebase, which is clean but rewrites hashes, so you never rebase what you have already shared. You collaborate through GitHub, remote add, push, clone, and pull, with pull requests as the place work gets reviewed before it lands. And you stay fearless because of the safety net, amend, reset, revert, and above all git ref log, which means nothing committed is ever really gone. The daily loop ties it together: pull, branch, commit, push, open a PR, merge, delete, repeat. I have put a free Git and GitHub cheat sheet with every command from this video on it in the description, plus a step-by-step guide on how to undo a git commit for when you need the deep dive. Grab them and keep them next to your keyboard. If you want to go further, there is an optional Git and GitHub mastery pack linked there too. Subscribe, go make a repo, and start committing. The only way this becomes second nature is by using it.